Alright, you guys, these first two pages are literally the hardest of this packet. The rest get kind of easy, but it's an exploration around rotations. It says this, we're going to learn how to rotate figures using a compass and a straight edge. I am probably going to use a protractor to do this. So, and then a straight edge, obviously, with that. So, if we look at this, it says ABC is rotated 90 degrees around point P. So we're going to assume that this right here was a rotation from here. We're going to draw a couple of these, right? So every point here is rotated around point P. So if I go to point P here, I go to my new point, right? That is a rotation around point P. Alright. Let's go ahead and do C at least. We might not do all three, but I want you to see. I want it to be kind of a little bit less busy than it would be if I put B, although we'll be doing that later. So, what if I do this? Measure the distance from AP to AB. So I'm sorry, to P, A prime, and it looks to me like this right here is roughly 2.5 centimeters, and this right here is also 2.5 centimeters. So the distance after the rotation remained the same, didn't it? And I can promise you the distance here remained the same. So when I rotate around a point, the distance to that point remains constant no matter what. No matter how far I rotate this center rotation, A will be the same distance, C would be the same distance, and B would be the same distance. So we found out that they were the same distance. And I'm just going to write same distance. Alright. What can you conclude about the distance of a point around the image of a point and its image from the center of rotation? They always remain the same. And this is an important point. Alright, so one of the main things we know when we rotate is whatever that point of rotation, often the origin when we do a regular one, the distance between the point and which we're rotating around remains the same. Kind of like a guy swinging something, a bat maybe, the distance of the bat. Or if you swing a rope with a ball on it, that ball is always going to be the same distance from you. It's just going to be at different locations. Alright. What advantages to using geometry software or tool? Well, geometry software does the measurement for you. I'm just going to say that software measures for you. Now, I want to point out that we know that this is a 90-degree angle because of this. Look, from this point to the new point is 90 degrees. I'm going to mark it perpendicular. Same here, from C to C prime is 90 degrees. I'm going to use these two facts, right? Same distance with a constant rotation for all the points to do some of these by hand. So here we go. Alright. A rotation is a transformation around point P called the center of rotation. Alright. Such that the following rule is true. Every point in its image are the same distance from P. That's our center of rotation, just like we saw up top. Alright. All the angles formed by the P and its image have the same measure. And this angle is the measure of the angle of rotation. We saw that up here with the 90 degrees, that being the measure of the angle of rotation. Alright. And let's do this. Let us rotate this triangle ABC 150 degrees around point P. So the very first thing I'm going to do is I'm going to draw a line from A to P. Here I go. Then I'm going to use my protractor to figure out where 180 degrees, 150 degrees counterclockwise, so this way would be. So I'm going to be as exact as I possibly can. And I should have brought a better light, but I can see it out here. I think. Did I do that upside down? Here's my problem. I'm reading upside down. Alright. So 150 is right here. And I'm going to draw a line to it. And then what I'm going to do is I'm going to measure that distance. And this time, you know what? It's pretty quick. I am going to use a compass to measure this distance. The distance from A to P is that much right there. I'll put that mark over here, and there it is. There's my mark. And this mark is going to be A prime. So what did I do? Well, I did my angle of rotation, and I made sure they had the same distance. This and this are the same. Let's do the same thing with C and B. Alright, so I'm going to draw a line to C, to right here. There's C. Comes in. I'm going to measure 150 with that. So here I go. 150 degrees. Goes to right there. I'm going to draw a line to there. Alright, somewhere like that. I'm going to measure the distance to C, which is right there. We can see that I have the distance to C. I'm going to mark that distance on this line, and it's not long enough. I'm actually going to have to extend my line just a little bit to get there. So let us do that. There. I'm going to call that C prime. Alright, we got one more to go. B, so I'm going to do the same thing. I'm going to draw a line to B. I'm going to measure out an angle of rotation. Using my point on that point of rotation, I put my circle in that point of rotation. I'm going to measure it out. 150 is right about here. I'm going to draw a line to 150. Here I go. To there. And then I'm going to make sure I have the same distance. So here I go, measuring out the distance to B. Let's hope I did it long enough this time. I may not have. I may have to extend my line. And I'm pretty darn close. There it is. I'm just going to hand draw this a little bit to there. And there's B prime. And if I connect these, and I realize it's a little bit of a pain in the butt, I am going to get this triangle with that center of rotation. Alright, so this triangle ABC rotated to here, ABC. And let's go ahead and do another one. Alright. So we're going to come here, and now we're going to do a clockwise rotation. Alright, so to the best of my ability, we're going to hit a clockwise rotation. I'm going to draw this line through D, and I'm going to measure on cue 75, and this time I'm going to turn this way clockwise, so I need 75 going this direction. So I go in here, and around here I pick 75, and I draw a line towards that direction. I probably don't have to make it quite that long, but let's make sure it's, there we go, towards that direction. So my D is going to be there, and once again, just a quick measurement right here with the safety compass. That's the distance. I mark it here, and so this would be D prime. Alright. Same thing. We're going to draw a line through E, and then we're going to rotate. There's E. I'll draw a line through E, and we're going to rotate 70 degrees again. So I mark this up. Was it 75? 75 degrees. Make sure I get that right line. I'm going to mark 75 on here, way out here. I'm going to draw a line towards that 75. And then, so that's my rotation. This would be a 75 degree angle. That's what I've rotated. So they all have the same angle. This would be a 75 degree angle, and I'm just going to measure how far it is with this protractor. Let me just show you that it's on there. I come over here and mark it. Put a little pencil mark on it. There's point E prime. I got one more to go. Alright, these two should be the same distance as these two. So I'm going to draw a line through F, and all we're doing is we're measuring an angle. We're drawing our new line at that angle. Alright, so here I go with F, hopefully. I think I'm on there, and I'm centered. Alright, I think I'm centered. 75 is out here. I'm going to keep my pencil there. I'm going to draw a line that I think will encompass F, and I'm going to measure the distance to F. So hopefully I drew enough. So I'm drawing the distance to F, and I mark it. There's my F prime. And all these angles should be 70 degrees around that. And they look, if you look at this, this is roughly the same triangle. This and this are the same triangle, rotated 75 degrees around that point. So we got one more to go. I am not going to do that closing task with you because we're already at 10 minutes, but I should be able to rotate this pretty quick. So I'm going to do something a little bit different this time. I'm going to draw all three lines. So I'm going to draw one from my L, I'm going to draw one from my K, I'm going to draw one from my J, which is very similar to my K, and I'm going to rotate them all, what does it tell us? 40 degrees this way, counterclockwise. So these are so close, they look exactly actually, so I'm going to go ahead and use the same one for that. So I'm going to use one 40 degree one for this and one 40 degree one for that. So let me get the first 40 degree that shares those 2 points. So 40 is right here. So this first one is going to rotate 40 degrees this way, 40 degrees this way. And this guy right here, if I do this correctly, let's mark my 40 out here. It's going to rotate. So this one is also 40 degrees this way, right? That's what it's rotating. So now all we got to do is get our three lengths, and we've got it. We'll start with K, since it's pretty darn close there. Right there. There's K. I'm going to stay and get J here, because it's on the same line. There's J. And then we're going to go to L with the other line, which is this distance right here. There's L. L prime, K prime, J prime. And if we connect those points, here's another straight edge. I got a couple sitting here at my house. We can see that, oh, let me draw that again. There. This triangle has rotated up to here. Anyway, try this one. Go try it. Draw lines, get your rotation, and then your distance. And that's going to be pages 1 and 2. We got some notes that are going to help us make the rest of this pretty quick. And we're going to keep this handy. Alright, talk to you guys soon.